I'm going to take you through how to work out the formulae of ionic compounds. So this is compounds that have got a metal and a non-metal, and these compounds will always contain cations and anions, positive ions and negative ions. You can't have one without the other, and the total charges have got to balance. So that's how you find out what the formula of an ionic compound is. You've got to have the same total positive charge and total negative charge. I'm going to show you how to work out the formula of an ionic compound. I'm going to go through a few examples. First one we'll go through is sodium chloride. First step, you've always got to know the charge of the ions, which I've shown you in a different video. Sodium is in group 1, so it's 1 plus. Chloride, group 7, is going to be 1 minus. So those are the charges of the ions that I'm working with. So I'm going to write those down. Na plus is 1 plus, and Cl minus, that's 1 minus. Now, for those charges to balance, I don't need to do anything. They're already balanced, 1 plus and 1 minus. So the formula of that is going to be, I need one of each, and they balance out. One sodium ion balances one chloride ion, so one of each, one sodium, one chloride, NaCl. Okay, let's try another example. We're going to go for magnesium oxide this time. Magnesium's in group 2, so it's 2 plus. Oxygen in group 6, so oxide is 2 minus. So I write down those ions with their charges, Mg2 plus and O2 minus. Now again, these balance each other out already. 2 plus balances out 2 minus. So the formula of that again is I just need one of each for them to balance. So the formula is MgO. Notice it's not Mg2O2 because I'm not writing the total charges. I'm writing the number of each that you need for it to balance out. So 1 Mg balances 1 O. So the formula is MgO. I'm going to try lithium sulfide now. So if we look at our periodic table again, we've always got to start there. Lithium is going to be 1 plus, and sulfide is going to be 2 minus. Let's get those written down. These time, they don't balance each other out. We've got 2 minus and only 1 plus. So we're going to need 2 of these to balance out one of these. I'm going to write that in. Now, if I've got 2 lithiums, that balances with 1 sulfide now. So the formula is going to be Li2S. That tells us there's 2 lithium ions balance 1 sulfide ion. Let's go for aluminium chloride. Aluminium is going to be 3 plus. Chloride is going to be 1 minus. So let's write those down. Al3 plus. Cl minus. This time we've got 3 plus as the total positive charge, but only 1 minus. So we need some more of these. So if we put in another, we've now got 2 minus. Put in another, we've now got 3 minus. So this is going to be our formula for this one. 1 aluminium ion with 3 chloride ions, so it's going to be AlCl3. Let's do aluminium oxide, which is slightly more complex now. Al is 3 plus, oxide is 2 minus. So let's write those down. Now, this is more, so let's try adding more of these oxide ions. Now we've got 3 plus and 4 minus, so they're still not balanced. So we're going to need to add another aluminium ion. Now we've got 6 plus, 4 minus. Let's add another oxide ion. Now we've got a total of 6 plus positive charge and 6 minus negative charge. So now they balance, and we've had to get 2 aluminium ions and 2 oxide ions for that to work. So the formula for that is going to be Al2O3. I've shown you the proper way of doing it so that you're actually working it out. There is a cheat way of doing it, which is that the charge of one ion becomes the number of the other ion. So the charge of lithium was 1, and that's the number of sulfide ions. The charge of sulfide was 2, and that becomes the number of lithium ions. Or in this example, the charge on aluminium was 3, so that's become the number of oxygen ions. And the charge of oxygen was 2, and that's become the number of aluminium ions. So you just swap over those numbers. That's the cheap way of doing it. To show you that that works, there's another example. You could use magnesium nitride, and that's got Mg2 plus ions and N3 minus ions. And if we do that method to get our formula, so we're going to have 2 of those and 3 of those. If you went the long way round and worked out balancing the charges, you'd get the same formula, Mg3, N2. So that method works. Just quickly then, the other thing to show you is what about if you've got polyatomic ions. So remember, there's some ions which are a bit more complex, which you've got to know the formula for, these ones. You can do the same thing. So for sodium sulfate, for example, sodium from our periodic table is Na+. And the anion in this case is sulfate, which is SO4 2-. Well, in this case, we need 2 sodium ions to balance that 1 sulfate ion. So if I put in another one of those, and the formula is going to be Na2 SO4. One more example, calcium nitrate. Let's do calcium. If we looked on our periodic table, is Ca2+, and nitrate, you've just got to remember, I'm afraid, is NO3-. 1- is the charge on that. In this case, we've got too much positive charge, so we need another one of these nitrate ions. So another one of those, and now the charges balance. So the formula is going to be CaNO3 2. The really important thing here is that you put brackets around the NO3. That tells us that that 2 there applies to everything inside those brackets. So there's 2 nitrogen atoms, because 1 times 2, and there's 6 oxygen atoms, because 3 times 2. Really important that you put the number there. In this case, we didn't need to put brackets around the SO4 because there's only 1 of them. So we're not putting a number outside the brackets. We don't need brackets around it. Only if you've got more than 1 of these polyatomic ions do you need to put brackets around it. And that's how to work out the formulae of ionic compounds.